Myself Jaypriya, and my presentation topic is classful addressing. Now we are going to see about IPv4 address. An IPv4 address is a 32-bit address that uniquely and universally defines the connection of a device, for example, a computer or a router, to the internet. What is an IP address? An IP address is a unique global address for a network interface. An IP address is a 32-bit long identifier, encodes a network number and a host number. What is network prefix and host number? The network prefix identifies the network and the host number identifies the specific host actually interfaced on the network. How do we know how long the network prefix is? The network prefix used to be implicitly defined, that is class-based addressing A, B, C, D. The network prefix is flexible and is indicated by a prefix or net mask that is classless. So, the address space of IPv4 is 2 power of 32 or 4. Classful addressing, the address space is divided into 5 classes, that is A, B, C, D, and E. And here is an example of what is a picture of network's prefix and host number. Now we are going to see about the world way classful addresses. When internet addresses were standardized, early 1980s, the internet address space was divided up into classes. Class A, in that the network prefix is 8 bits long, and in Class B, the network prefix is 16 bits long. In Class C, the network prefix is 24 bits long. Each IP address contained a key which identified a class. Class A, IP address starts with 0. Class B, IP address starts with 10. Class C, IP address starts with 110. You can see now the picture of the internet address classes of Class A, Class B, and Class C, and Class D, Class E. Problems with the classful IP addresses are the virtual classful addresses scheme had a number of problems. Problem 1. Too few network addresses for large networks. Class A and Class B addresses were gone. Problem 2. Two-layer hierarchy is not appropriate for large networks with Class A and Class B addresses. Problem 3. Inflexible. The customer company requires 2000 addresses. Class A and B addresses are overkill. Class C addresses is insufficient. Problem 4. The internet is going to outgrow the 32-bit addresses. In classful addressing, a large amount of the available addresses are wasted. Finding the classes in binary and dotted decimals. Here you can see an example of these. And somehow you can see the pictures of blocks in Class A, Class B, and Class C. Now we are going to see about subnetting and supernetting. To overcome the flaws of classful addressing, these two solutions were introduced to compensate for the wastage of addresses. It is discussed them one by one. Subnetting. As class blocks of A and B are too large for any organization, so they can divide their large network into smaller subnetwork and share them with their organizations. This whole concept is subnetting. Superrating. As the blocks in Class A and Class B were almost consumed, so new organizations consider Class C, but the block of Class C is too small than the requirement of the organization. In this case, the solution which came out is supernating, which grants to join the blocks of Class C to form a larger block, which satisfies the address requirements of the organization. What are network addresses? The network addresses is the first address. The network address defines the network to the rest of the internet. Given the network address, we can find the class of the address. We can find the class of the address, the block, and the range of the addresses in the block. It can be found by applying the default mask to any of the addresses in the block. It retains the net ID of the block and sets the host ID to 0. A mask is a 32-bit number in which the n leftmost bit bits are 12s and 32 and rightmost bits are zeros. However, in classes addressing, the mask for a block can take any value from 0 to 32. It is very convenient to give just the value of n preceded by a slash. We must not apply the default mask of one class to an address belonging to another class. You can see an example of masking concept and operation. Here it is the number of blocks and block size and classing IPv4 addressing. Class A consists of number 128 number of blocks and in application it's unicast. Class B consists of 16,384 blocks and application is unicast. Class C is 2,97,152 number of blocks and application the same unicast. Class D consists of 1 blocks and application is multicast. Class E number of blocks is 1 and the application is reserved. Multi-home devices. A device has different addresses network connected to it. Such devices are called as multi-home computers. Each of these addresses can belong to a different class. The router has more than one IP address, one for each interface. Here is an example of direct broadcast address. Host IDs are all ones. The direct broadcast address is used by a router to send a message to every host on a local network. Every host or router resolves and processes the packet with the direct broadcast addresses, and you can see a diagram to understand it completely. Loopback addresses. IP addresses with the first byte as 127, known as loopback addresses. It is used to test the S by W on a mission. Here, the packet simply returns to the protocol SW on the same mission. Example, ping Apple to test if the process available to receive and process a package. We can say another example, client process sending message to server process on the same machine. A diagram of special addresses. And here we can see some examples for supernetting, subnetting, and how we have converted the decimal dotted numbers into binary, and from decimal notation to binary notation. Here, the first example we can say about is given the network address is 17.0.0.0. Find the class, the block, and the range of the addresses. It is class A because class A is 128 and 17 is below that, so it is class A. The first byte is between two, like was 0 to 127. 17 is same, so it is between 0 to 127, so it's block A, class A. The block has the integer of 17 and the addresses range from 17.0.0 to 17.255.255.255. And here we can see the another examples of same type. Slight changes is the uh, classes. Here it is given 132.21.0.0 as the first byte is between 128 and 91. The class is the network given address is 132, so the class is P. For example, the network address given is 220 and the first byte is given 192 to 223, so the class is C. Same goes with the other examples. Here they have given the address 23.56.7.91 and they told us to find the beginning address. So the default mask is 255.0.0.0, which means that only the first byte is preserved and the other three bytes are set to zeros. So the network address is 23.0.0.0. And the other address, second example, given the address 132.6.17.85. Here they also told the same find the beginning address. Here the default mask is 255.255.0.0. which means that the first two bytes are preserved and the other two bytes are set to zeros. The network address is 132.6.0.0. This is particular of classful addressing. If we consider class A, the number of addresses in each block is more than enough for almost any organization. So its result in wastage of addresses. Same in case with class B. Probably an organization. Specific block from class B would not require that much of addresses. So it also results in wastage of addresses. A block in class C may be too small to fulfill the addresses requirement of an organization. Each addresses in class C defines a group of hosts. Host needs to multicast the addresses, so the addresses are wasted here too. Addresses of E class E are reserved for the future purpose, which is also wastage of addresses. The main issue here is we are not assigning addresses according to user requirements. We are directly assigning a block of a fixed size, which has a fixed number of addresses, which leads to the wastage of addresses. So this was all about the classful addressing. This addressing leads to wastage of addresses. Subnetting and supernetting also fail in resolving the problem as they make the routing of packets more difficult. So classless addressing was introduced to cope up with the failure of classful addressing. Thank you.